I'm Dave Nardman. Today I'm going to show you how to assemble and use a high-powered laser. Now, let's talk about lasers. Lasers are a pretty modern invention originating in the 1960s. The word laser is actually an acronym which is short for Light Amplification by Stimulated Emission of Radiation. Simply put, it intensifies light to a specific frequency. Most people are familiar with Class 2 laser pointers, which range from about 5 to 10 milliwatts. Class 3 lasers are what you would find for reading and writing CDs, DVDs, and Blu-rays, and they can be as high as 500 milliwatts. Anything more is considered a Class 4 laser. This 2-watt laser module comes with a little bit more than just a diode. It comes pre-terminated and with an adjustable focusing lens. Unfortunately, I can't just hook this module up to a battery or my power supply because there's no current limiting. My design is a small variation on the current limiting circuit that can be found in the LM317 datasheet. You can find the link in the description. I will use an LM317 adjustable voltage regulator, 2 electrolytic capacitors to smooth the output current, and a current limiting resistor. The output current will be 1.25 divided by the resistance. Chances are we'll need a very specific resistor value. Where there's a will, there's an equation, typically. For resistors in parallel, the final resistance is the inverse of the sum of 1 over each value. So a 5 ohm resistor would be 5 ohms, 2 5-ohm resistors would be 2.5, and 3 would be 1 2/3, and so on. Or if you don't want to deal, just use a potentiometer. So the first component I'll add is the LM317 voltage regulator. And at the bottom I'm going to add a negative wire for ground. And between those will be an electrolytic capacitor. The next pin in is the output. This is where I want my resistor. I have these 3 resistors all tied together for a grand total of 1.25 ohms, approximately, which means my output current should be limited to 1 amp. The third pin is the adjust, and we want that to connect to the same place as the other side of the resistor. Once again, we're going to want a capacitor, and we want that end to be shorted to ground also. I'm going to continue this so that it can be ground for the laser as well. Finally, with the adjust and the resistor both end, this is going to be the positive for my load end. These 2 output wires are current limited, so if I just take them and short them at 10 volts, I'm drawing just under 1 amp. Another nice thing about this circuit is that its output voltage is pretty consistent. You can use this LED to demonstrate the effects of this board on a diode. Now our laser is assembled and ready for action. I'm going to wear these fabulous laser safety glasses. There are specialty laser safety glasses that emit very specific frequencies of light. I'll include a link in the video description. The only other thing to worry about is that whatever the laser is pointed at is going to get extremely hot. So make sure that it's pointed at something solid and non-flammable, like concrete. So now I'm ready to give it some power. This particular diode has a forward voltage of about 4 volts. Through the lens of these safety glasses, I can't even enjoy the laser. Here's what I see. Yeah, underwhelming, isn't it? So this laser beam should be pretty intense. Intense enough perhaps to burn through a sheet of paper. Let's get back to safety for a moment. So you might be inclined to save money on these glasses that filter out the blue wavelengths of light. Maybe you think, hey, I'll be alright with transparent safety glasses. Apparently not. Welding goggles gotta do the trick, right? Well, let's find out. They most certainly do not. People out there are gonna try this anyway. Sunglasses. that dot on the concrete there, that's all the light that's not being stopped. Check it out. That pattern you see on the concrete is the melting lenses of the sunglasses, and it's changing the refractive index and scattering the light.